Okay, welcome CHEM8C students. Today we'll be going over part 2 of this week's worksheet. Okay, so the first two questions are retrosynthesis, and I know that because of the type of arrow indicated. And Dr. Larsen mentioned in her notes that anytime you have this type of base catalyst, so if I had R2NH, just like this, so R1, R2, then all you do is you look at the alpha beta position, counting from the ring, and you cleave that section right there, and you get something like this. Right? But I need something on this side right here. So I can just add any type of good leaving group. So for this purpose, I'm just going to add Cl halogen. And that's it. These are your two reactants to make this product. Okay, so for this next one, I know that I'm doing a retro aldol. And that's because I have this beta hydroxy ketone. So I have alpha, beta. At the beta, I have this hydro group, and then I have a ketone. That's why it's called a beta hydroxy ketone. So in an aldol reaction, to get the reactants for this, you just cleave off the alpha beta position, and you form something like this. So in replace to where that bond was, you're going to just add a hydrogen. And where that alcohol is, it gets replaced by an carbonyl, and this forms an aldehyde, and then here you have your ketone. So if this was aldol condensation, then the alpha beta position, let me do this in a different color because it is something that I want to note. This alpha beta position is actually going to form this, I'm sorry, there's no bond there. It's going to form this unsaturated part. So you have alpha, beta, in between that you have that double bond, which is what makes it unsaturated. And that's what you would get for this one. And then there's a methyl group there. But yeah, you would just get that. For this, they look pretty identical, right? Minus the whole OET being here, an ester here, and only a carbonyl on this left side here. But that's because the OET that was included in this part right here acted as a leaving group. And I can actually draw the mechanism to prove this to you guys. So I know that, let me just write out the reactant for this retrosynthesis. So it's going to be this. And it's actually going to be 2 times that. So I'll just put 2 times. And let me prove that to you guys. Also, you need some type of base. And this R group has to match the R group that's there. So let me prove that. So if I react this ester group, right? So I have the dissociation of Na plus and OET minus. This is acting as a base. It's going to grab one of the hydrogens at the alpha position. Well, there's only one in this case because you have 2 other R groups. So it's going to grab that hydrogen, and then you're going to get a bond that forms here, and then that's going to kick the electrons up to oxygen. And you get something that looks like this. Like this, okay? And then this is going to want to push back into a carbonyl, and then you have another equivalence of that ester, right? So this is going to act as your electrophile, and then the double bond from the alkene is going to kick, or it's going to attack at that position. That's going to kick this up, and you end up with something that looks like this. So it looks kind of funky, but let me highlight which parts are what. So this right here is this group. And then this right here, so we have the carbonyl that kicked up its electrons to oxygen. Then we have the attached OET and then the R group. And it's all on that one carbon right here. It looks kind of ugly. I apologize for that, but these drawings can get messy when you draw the mechanism of it. But what happens is that when these electrons go back into to form a carbonyl, this acts as a good leaving group. And that's what ends up with this structure here. So you get that. Okay, so for this next Claisen reaction, we have our two esters. And the first thing we have is a base, right? So this base, it's going to find one of the two that has the alpha H. This one doesn't have an alpha hydrogen. It is an alpha position, but there is no alpha hydrogen, so it's not going to attack at that position. Instead, it's going to use this one. And so it's going to grab a hydrogen from that alpha position. The bond between carbon and hydrogen is going to form an alkene, and that's going to kick this up. So we get something that looks like this. Okay, so the next thing that happens is the electrons from oxygen is going to pull down to form a carbonyl again. And this is going to act as a nucleophile to attack the electrophile. And then we have the added group here. So I'm just going to count my carbons because it's very common for people to miss carbons. So we have 1, 2, 3. We have 1, 2, 3. So we can proceed. So the next thing that happens is that the lone pairs on oxygen are going to push back. And this OME is going to act as a really good leaving group, which leaves this as the answer. Okay, so we're not done yet because then the next step of the reaction is reacting it with NABH4. And I wrote down here that NABH4 is good for reducing aldehydes and ketones into alcohols. So this is the only ketone here. This is an ester, so it's not going to get reduced. And you end up with this. Oh, sorry. You end up with this. Okay, and that's it for this worksheet. If you haven't signed in yet, please sign in into the description box. Thank you.